Good morning, good afternoon, good evening, everyone. Thank you very much for attending this webinar. My name is Virassamy. I will be hosting this session today. I'm a cloud solutions architect working for Mirantis for around 5 years now, and I've always been in the space of open clouds with Linux operating system, OpenStack clouds, and Kubernetes. So today we'll be talking about how actually you would be able to migrate your workloads from VMware to these open clouds. What do we have on the agenda today? So we'll just do a quick reminder of what are some of these open cloud options. Why? Because this is a series of two when we decided to do this, this session. The first one was more concentrated on or more focused on the infrastructure part. So what are these options? And then the second session, which we are doing now, is related to the recipes to actually migrate these VMware workloads towards these clouds. So we'll do a quick reminder of what we saw the last time during the first session, and then we'll look at these two recipes, one for VMware towards OpenStack and one for VMware towards Kubernetes. Rapidly, what are some of these available major open clouds, and what did we see the last time? So just quick reminder, this was a webinar that I did on October 31st. Do not hesitate to go on BrightTalk and listen to it. On that specific session, we actually look at why open source is not a concern. We have tons of very robust and useful open source projects in the market, whether it is related to databases, message queues, clouds, container orchestrator. You have companies actually like Mirantis that have spent the last 10 plus years making sure that open source is consumable and can be supported, right? So open source is definitely not a concern when it comes to managing open clouds. OpenStack is one of these options. Why OpenStack? Because it's a rock solid solution. We don't really want to compare it with VMware because it's like Orange versus Apple comparison. There are similarities. There are things that VMware does in a very, very specific manner, and there are things that OpenStack does in a very, very specific manner. But we can say that today OpenStack is at the age of maturity, meaning that always like comparison of OpenStack and Linux actually, right? So we had two operating systems. We had Windows and we had Linux, and it took time for Linux to be that operating system that we know today, right? So something that which is easily consumable. You have tons of cloud images today, and you can just consume Linux without having to compile the kernel or knowing or understanding how all these parameters need to be set to have an operating system up and running. So OpenStack is the same. It started back in 2012. It took 10 years to become at that stage, meaning that now you have these very, very solid components within OpenStack, and you can consume OpenStack in an easy manner, right? This is how many very large, iconic companies are using and consuming OpenStack today. So we also looked at that in the previous session. Basically, in the enterprise domain, in the telco domain, and in the cloud service provider domain, you can see very large footprints of OpenStack. And used to host very, very critical applications, right? We also shared some of the recipe to succeed with OpenStack, and these are to work with a proper partner that can help you design the cloud, deploy the cloud, and maintain the cloud, right? So if you do that properly, do proper designing, proper deployment, and proper maintenance of the cloud, this is definitely the right path to succeed with OpenStack. And finally, we talked about how OpenStack is also a great solution if you wanted to reduce your TCO, so total cost of ownership. And this is very, very true at scale, right? So we provided a link, and added this again in this session towards a TCO calculator, very simplified TCO calculator that just compares some of the cost element of OpenStack and some of the cost element of VMware. But if you do want to have a more detailed TCO calculation, do not hesitate to reach out to us, and we can do that simulation with you with a more complex model. The second thing that we also looked the last time was to have a more disruptive approach with Kubernetes. So instead of looking at VMware versus OpenStack, was more to look at VMware versus Kubernetes. And for that specific solution, we looked at the pros and cons of refactoring applications versus a very simple lift and shift, right? And there are some very, very, you have benefits or you have advantages of not refactoring all your applications upfront, but start rapidly by lifting and shifting your applications from VMware and move that towards Kubernetes to start to modernize your platform, right? So to stop the legacy platform running VMware and move towards a more modern app platform with Kubernetes. Manage only that single platform, lift and shift applications rapidly, right? So these you can do very rapidly. And then afterwards, start to look at very specific applications that needs to be refactoring. And because we know that refactoring will take more time to do, right? So you have these pros and cons, and lift and shift is definitely a very valid solution. We also looked at what about running VMs in Kubernetes? Because we know that, again, VMs is not going to go anywhere for the next 3, 4, 5, maybe more years, right? So we still need to have VMs and we'll not be able to replace all these VMs by containers. So for that, one, OpenStack is that solution, or two, in some cases, Kubernetes and KubeVirt in that combination, it can be also a good solution, right? So again, we have that option of VMware towards Kubernetes plus KubeVirt to manage some of these VMs. So now let's look at what is important for what I wanted to share during that session. So the last time, as I said, we looked at the platform part or the infrastructure piece, right? But you can tell me then, okay, I have VMware, I have now deployed my target environment, whether it is OpenStack, whether it is Kubernetes, whether it is both. How can I migrate my application? So let's look at the first recipe, which is moving from VMware towards OpenStack. So for that, Mirantis, we have designed a solution that I'm going to describe here. And that solution is basically running in two major steps. The first one is we do some discovery and planning, right? And that's what we call, and we'll typically do during these a couple of migration workshops. So we start with that first element, which is I want to do a migration workshop. And during that migration workshop, I'm going to discover and plan the different steps to migrate the applications from VMware towards OpenStack. The second step, big step, is what we call the platform engineering part. And that platform engineering part is then the analysis and design of the migration process, right? So we know the applications, and then now I'm going to analyze and design what needs to be done in the migration tooling to be able to migrate the workloads. Then I'm going to migrate the workloads, and then I'm going to validate that, right? So these are the big steps that I'm going to run during that migration project. All of that is covered under a governance body, and that governance body is made of both Mirantis employees and the customer employees, so that we can, in a continuous communication mode, we can exchange rapidly on what we have discovered during the migration workshops, planning, what we are discovering during the platform engineering, and how we can reiterate rapidly to make sure that things are working fine, and also communicate properly with the external bodies to make sure that everything is under control, right? And all of this will take a couple of weeks, and these couple of weeks will also be defined during the planning phase, simply because it depends on a various amount of parameters that I'm going to detail in the next slides. So let's start with the discovery and planning phase. So for the discovery and planning phase, basically, this is a combination of tooling that we are going to use, right? So auto discovery tooling and questionnaire and other artifacts that we are going to use with our customer to make sure that we understand the proper application portfolio, right? So this is always interesting to do in all cases so that you get a proper updated map of your application portfolio, whether you're going to migrate your application or you are going to make some decisions on which applications you are going to migrate. This is always nice to be able to do the discovery of your application portfolio, and as from there make some proper decisions, right? So during this discovery phase, again, it's tooling, tooling that we'll be using, self-service questionnaire that we'll be using, and as an output, we will provide that application portfolio map. As from there, we look at the planning phase, and the planning phase is basically, well, we look at the workloads maturity, and then as from there, we classify and provide or give a priority to which applications needs to be migrated first, right? So we kind of define that dependency map so that we can properly plan which workloads needs to be migrated and in which maintenance window, right? So as from there, we will define these maintenance windows with the customer, right? And within these maintenance windows, we'll be able to plan properly which workloads we need to migrate and how we need to migrate that, right? So this is done during that planning phase. Once this is done, then we can start to look at the tooling. So again, we have a set of tooling, mainly based on open source tooling that we have built, right? And the tooling is fully customizable, right? So what I mean by that is we can, based on what we have discovered, do the analysis of the different migration model that we have as templates, and then modify during the design phase these migration model so that the tooling is adapted for the customer use case. So as an example, let's say, for example, you're using one or two provider networks on VMware, right? And you want to replicate that same model on OpenStack. We can do that directly and say, okay, you have your provider networks on VMware, and I need to recreate these provider networks on OpenStack first, and then I'm going to hook my virtual machines on these provider networks. Another option would be to say, okay, I am using provider networks on VMware, but I want to use a more modern way of doing networking on OpenStack, and I want to use overlay networks, right? In that case, we can do and adapt the migration model during that analysis phase, and then the design phase, we implement that, so that when we migrate, we are taking into consideration the migration decisions and build these overlay networks within the migration strategy, right? So all of this is where we start to customize and make sure that we are able to adapt the migration model templates based on the customer requirements. Okay. Once this is done, then we can start the migration phases, and for that, we will be doing that during specific migration windows. We can run these migration steps in parallel, and I'm going to give you a little bit more details on how we do that, but we are able to do things in parallel so that we increase the amount of workloads that we are able to migrate during that migration phase, right? And once this is done, then the customer validates these VMs. The source VMs are never destroyed, right, automatically by the tool. So we keep them as is. We have started the new VMs on the target environment, which is OpenStack. They are validated, and once they are validated, the customer can decide to delete or archive the source VMs somewhere, right? But that's to the decision of the customer, right? So we will never delete the initial or the source application, which means that at any point of time during that phase, we can roll back and restart the initial VMs, and the service will be provided by these initial VMs, right? Until we fix iteratively any issues that we have found during the migration phase. So what are some of the specificities we have taken care or implemented during the migration of these images? Well, the first thing is we are trying to do as much as possible a one-to-one copy of the original image, right? So we have a good feature in VMware, which is exporting the OVF image. So all the data is transferred as an OVF image, which contains all the metadata and the actual data volumes, right? Once the OVH file is downloaded inside what we call a worker VM. Okay, then we unpack these the different volumes. We parse these volumes to understand which one is the boot volume and which one are not bootable volumes. We attach these volumes to the worker VM, and then we start to transfer these into OpenStack Cinder volumes, right? So we do that data transfer, and once the data is fully transferred, then we are ready to start the VMs. Okay, so that's the big principle behind that migration tool. Is we do that one-to-one copy by transferring the OVF file, detecting which files are bootable, which one are not, attach all these volumes, create new volumes on OpenStack, and transfer data. So that's one thing. We know that when we are doing these bootable volumes, we do need to do some manipulation within these VMs. But that's all right, because as I said, we are never going to delete the source VM. So the source VM is still there, and if we need to roll back, then we are not going to take back the VM from OpenStack and move that back to VMware. The VMware initial source image is still there, right? But in the target image, we need to do some manipulation, and we are using libguestfs to do that. And why we need to do that is we need to uninstall some drivers which are specific to VMware, like the network driver, for example, VMXNet 3, specific to VMware, and we are replacing that with something which works better with KVM, right? So we do some of these driver manipulations within the volumes before booting. Another thing that we are also taking care of is we are trying to map some of the objects from VMware towards OpenStack. As I initially said, you need to remember that we are comparing apples to orange, right? So VMware works in a very, very specific manner, and OpenStack works in a very, very specific manner. So there are things that do not exist in VMware that we need to map into OpenStack. Some examples are flavors, right? So you don't really have flavors in VMware. You have your templates, and once you have your templates, your image templates, you can create your virtual machines. But you don't really have that definition of flavors. So what we typically do in that case is while we do the introspection of the VMs before doing the transfer, the OVF transfer from VMware towards MOSK, what we try to do is we try to map or create a flavor or map a flavor which is as close as possible to what we have discovered on VMware, right? So let's say, for example, we are looking at the VM on VMware, and we see that it's using 8 CPU and 16 gig of memory and 80 gig of disk. We are going to try to map that to the closest flavor that we have on OpenStack. Obviously, we can create as many flavors as we want, or predefine as many flavors as we want in OpenStack, and the tool will automatically try to map that as closely as possible to what we have done or we have scanned when we are doing that scanning or / analysis or discovery phase, right? So that's an example. SSH keys is another example, right? There's no real way of handling SSH keys in VMware. Again, you're building templates. You can try to manipulate things with Cloud Init and all that, but it's a little bit tricky in VMware, and in OpenStack, that's a very standard feature, right? So you push your SSH keys, and dynamically you have the Cloud Init, which is used on these images to push your images, to push your keys within your virtual machines. Okay, base image, so templates and map that towards some base image. In VMware, you have the concept of clusters, vClusters, and folders, which doesn't really exist in OpenStack. In OpenStack, you have the notion of projects or tenants. So again, we have the ability to kind of map either a vCluster towards a project, or the whole vCluster towards a project, or we can map a folder where, again, we can manipulate, or we can tweak the tool during the analysis and design phase to make sure that we are able to map it as closely as possible to the original customer. And the last thing, which is a little bit specific between VMware to OpenStack, is that when we are going to copy that image, we know that we are going to use for a certain period of time some additional disk space, right? Simply because when we are going to download the OBF files and move that towards a volume in OpenStack, we are going to have some zeros, right, in the image, because it's not a copy on write image which is directly created. So what we need to do is we need to trim all the zeros to reduce that space afterwards, right? So that's what the worker node is doing. So we download the image, we mount the volume, we create another volume, and then we trim all the zeros, and then we copy the data so that we don't overuse the storage space, right? So in that case, we have a target with a given size, trimmed, smaller size, new volume in OpenStack, and then we copy the data. As I said, there are things that we can migrate from VMware to OpenStack. There are other things that we need to kind of try to map. And there we have various ways of mapping these, or we can define some default properties. Things that we'll not be able to copy or map is snapshots or quota, right? That's something that we don't include in the migration phase. But virtual machines and disk images are migrated. So if you have virtual machines or any disk images in VMware, then we'll be migrating them. We discussed a little bit about SSH keys. That doesn't really exist in VMware. There's no single base where you can retrieve all these SSH keys and import them into OpenStack. These will need to re-import these, right? So again, we can automate all that, but we'll need to re-import all these SSH keys and apply that to these VMs afterwards. Security groups, the same thing. If you're using NSX, then you have your specific micro-segmentation rules. Today, we are not mapping these. We could work on doing some automation. But by default, we'll be defining some default security groups. If we need to remap proper security groups to do more advanced micro segmentation in between VMs, we can do that. But again, we'll need to do some adaptations, because again, it's very, very specific to the implementation of VMware that many of our customers have. Network and subnets, yes, we can map these. We are discovering the networks before we are stopping the VMs, actually. And we are also retrieving the IP address that these VMs are using, so that when we are restarting these VMs in OpenStack, we will try to give the same IP. That's not mandatory. If the customer asks us to do something else, then we can readapt that. But yes, if, let's say, for example, we are going with on the direction of provider networks, then we can manipulate the MAC addresses, and the external DHCP will be able to provide the same IP because the MAC addresses will match. If we are using overlay networks, then we can create overlay networks, and we'll try to map the floating IP with the IP, the same external IP that the virtual machine had on VMware, right? And then projects, yes. We can also map projects, as I said. Either we map it on the notion of vClusters, or we map it on the notion of folders, right? And again, it can be a mix. Some of the tenants can be mapped towards vClusters. Some of the tenants can be mapped to folders, right? Can be a mix of destination projects. In terms of operating system, the tool supports all major Linux distributions and all major Windows Server distributions. You have that list in the table that I'm showing. Please note that for Windows 11, we did test successfully the migration from Windows 11 on VMware towards OpenStack, but there are some specific features that has also been implemented related to hardware verification that can lock migrations, right? So that's why here we say supported no, because we know that it can be a little bit tricky. But for the rest of it, yes, they have been tested, and we know that it works pretty well when it comes to migrating from VMware to OpenStack. So how do we do that in a little bit more detail? Here we are massively relying on automation, right? So we build a set of tools, and that set of tools, many around open source components. Some of these open source components are running in Kubernetes, right? We are leveraging Argo CD to build the pipelines. We are leveraging Ansible for automation. We are leveraging tools like V2V and libvirt to manipulate the images, right? So we are managing all these major components and integrating all these major components to do all this automation. And why we are doing this automation is simply to reduce human intervention. That means less effort and also less errors, right? So during again, if you look or remember the different stages, we do the discovery and planning. And once we do that, we do the analysis and design. So during the analysis and design, this is where we are going to readapt these different steps to make sure that we align properly towards customer environments and use cases, right? So again, we develop code within these different steps, and we very rarely do any human intervention. We try to build these automation first. We can try these automation in a staging environment, and then we run that in production environment. Okay. You have a centralized automation. So what I mean by that is we will be creating what we call a service tenant. This is what you can see here, the service project. And within that service project, this is where we'll be running our automation host, right? And this is where basically you have a Kubernetes VM, and that Kubernetes VM will be running all the different pipelines. Once we have defined that service project where you have Argo CD running, right, we will start by discovering virtual machines in VMware. So what will happen is that we will connect that service VM automation host. We will connect that to your source VMware cluster with the proper credentials and proper licensing or licenses, required licenses, right, to be able to access the VMware cloud using the VMware APIs. And as from there, we will automatically discover the VMs in the different vClusters and folders that we are authorized to access. And we'll create automatically a spreadsheet. And that spreadsheet will be used for all the estimation work afterwards, right? So that's the beginning of the, I would say the project is we start to gather all the facts within the different projects, right? So that's what you can see here. We have the Argo VM, which is created, connected towards VMware, and then we start to gather all the facts of all the projects, and from there we can define that spreadsheet. Okay. Once this is done, then we do the planning using that spreadsheet, and once we have that planning done, we start and let's say we have adapted our tool chain, then we start to do the migration, right? And that migration will be in parallel. That migration can be in parallel on a tenant level or on a VM level. And what I mean by that is we will, and let me just move towards the next slide. So what will happen is that once we have decided how we are going to move from VMware to OpenStack. So let's say we want to move a cluster inside an OpenStack tenant. Okay. So what will happen is that we will create what we call a worker node. So that's a VM that will temporarily run in that given target VM. And that VM will then connect to the VMware cluster, stop the VM, download the VM in OVF format. So we export the OVF container, right? Then we convert that image into bootable and non-bootable volumes. Once we have converted these VMs, we attach it to the worker host, and then we transfer data into Cinder volumes. Once this is done, we detach all the volumes, and then we start to boot the VMs using the bootable volume, and we attach the FIPS floating IP, if we are using floating IPs, with the same IP that we have discovered initially from VMware, right? So the green part is from the source. So this is where we connected to the VM, connected to vSphere through the APIs, discover the networking info, discover the I would say resource consumption info, and then download the VMs. And in parallel, in the target environment, we are creating any network that we need to create, convert the images, copy the data, restart the restart the VMs, and reassign the proper IP, right? Once all of this is done, then the customer will do the basic tests. We can consider that the migration is successful, right? And then it's up to the user to decide to delete the original image or not. If not, then we will reiterate so that all the tests are properly done, right? So once this is then done, all the applications in the source environment, again, the example was a folder. When all the applications have been migrated, let's say from a folder inside OpenStack, then the worker node in the tenant will be automatically deleted, and all the unnecessary artifacts will be cleaned, and the tenant will be then usable by the customer. So all of these will take multiple iterations, and this is how we define the migration windows. What we will be looking in defining these migration windows would be the workloads, the amount of workloads basically that we need to migrate, right? So that's one of the elements that we are looking at, amount of workloads that we need to migrate, the amount of data that we also need to migrate, so the amount of persistent data basically that needs to be moved from one environment to the other. Okay. Once we have seen that, and we also looked at the workload properties itself, right? Are there existing automation process in place? Are you using Terraform to deploy your applications on VMware? Can this be reused or redefined for the target environment, right? So we'll be looking at all these different things. Once the workload items are looked at and the provider items are looked at, two important things that we will definitely need to check in the infrastructure level, and I think this is where that defines basically a lot of the constraints in migrating. One is storage I/O. So the speed we can read data from the source environment and migrate that into the target environment, right? Because again, we don't do any in place migration. We are not taking existing volumes and we're attaching that to new workloads. We are migrating. We are creating new volumes and we are migrating that. And then all volumes can be deleted. So we have that dependency on storage capacity. So that's one thing. And the second thing is networking, right? So north-south traffic here is also very important because we are copying data, OVF container and any data, any other data that is required from VMware towards OpenStack, right? So we have these two constraints on networking and storage. Okay, so this was recipe number one, where I detailed a little bit all the different steps of migrating from VMware to OpenStack. If you do want to see a demo, or if you want to run a proof of concept of what I've showed, do not hesitate to reach out to us. We'll give the details at the end of this presentation, and we'll be able to basically show you how actually these two works, right? Again, don't hesitate to reach out to us. So now let's look at the other approach, and the other approach is what I typically call the more disruptive approach. So here we are talking about VMware towards Kubernetes, right? So what that means is basically I'm moving from VMs towards containers. In this case, what I'm going to show in this recipe is we are not going to talk about refactoring, because refactoring is something which is, again, very specific, and we can spend quite some time on this. Here, what I'm going to mainly talk about is lift and shift, right? So again, the idea here is I want to rapidly move away from VMware and I want to use Kubernetes as that target environment, but I can't spend the next 36 months rebuilding all my applications and moving all my applications into a more modern app microservice type architecture, right? What I want to do is rapidly move away and move my VMware estate into Kubernetes. And for that, the lift and shift approach gives or provides the advantage of being quite fast, right? So I'll give you some numbers and KPIs in how fast you can actually move your applications from VMs to containers and start to use Kubernetes as your main platform, right? And once this is done, once you have that Kubernetes as your main platform, then you can start at cherry picking specific applications and doing the refactoring of these applications. So this is what we call Mirantis Application Migration and Modernization Platform, AMMP. AMMP basically allows you to migrate applications from virtual machines or bare metal environments into containers. And these containers would be running in Kubernetes. Very important thing, and I didn't mention that in recipe number one. The recipe number one takes into consideration VMware towards OpenStack and any OpenStack, right? So it's not only Mirantis OpenStack, you can do that on any OpenStack. The same here with the AMMP. It's VM and bare metal, not only on top of Mirantis Kubernetes engine, which is our Kubernetes solution that is used across the market, massively used across the market. But you can deploy these containerized applications on any Kubernetes solution, right? So we are pretty agnostic in terms of migrating applications on any of these available clusters. Obviously, we have the advantage of providing both platform and the migration tool, so we can definitely help you host the platform and migrate your applications on top of that. But we have that flexibility and agnosticity to also support other platforms, other operating system. Does it need to be Red Hat operating system? Does it need to be on VMware? Does it need to be with SUSE Linux, right? You have that flexibility and choice of selecting your platform and underlying infrastructure actually, whether it is on-prem or on public clouds. So how does that work? So again, it all starts with an assessment step. That's the base, right? We need to understand from where we are going, to know how we need and to migrate these applications and what are the different steps that we need to go through to actually do the proper migration, right? So that's what we call the workload analysis and also X-ray of these applications to get a deep understanding of the applications. And we build the reports out of that, right? Similarly to what we've seen earlier with the spreadsheet, which we will be using automatically generated spreadsheet that we'll be using to plan the migration. The same here. We will be defining or building the reports either for the technical team or for the decision makers, where we'll be able to provide intelligent recommendations on which applications we would recommend to migrate, which we would recommend to retire, the amount of investment we think is required to migrate these applications, and based on that, we will basically rationalize, right? So we will decide, do we want to reinvest, meaning rehost, refactor, or do we want to replatform, meaning, do we want to reinvest in terms of rehost, refactor, and replatforming, or we want to retire or retain these applications? So these are all based on these intelligent recommendations. From there, we then start the transformation phase, and that transformation phase is an iterative process. This is the transformation of these VMs from VMs or bare metal machines, or applications running in VMs or bare metal machines into containers, right? So we containerize these applications. For that, we are building the Dockerfile artifacts, and we are configuring, tuning these Dockerfile artifacts to make sure that these applications are properly built as containers. We define the blueprints of these applications so that they can run properly in Kubernetes, and then we deploy these in Kubernetes, right? And then we reiterate to make sure that based on the testing results, we are adapting the Docker files again, making sure that the transformation is as good as possible, redefining the blueprints, like how many replicas we need, how do we expose the services using service objects, do we need to deploy an ingress, do we need to define or redefine some secrets or map some parameters in config bus, right? So we redefine all these blueprints and then we redeploy until the applications are properly deployed, right? All of this is through as much automation as possible. So the assessment is done with automation. The rationalization is done with the aid of these intelligent reports, providing the recommendations. And then the transformation blueprints and deployment is also automated with Docker files that are automatically generated, blueprints that are automatically generated, deployment that can be automated using CI and CD principles, right? Again, to reduce the amount of human intervention, human effort, and to increase the speed and agility of migration, and also reduce errors during this migration phase. Okay. This is an example of a report. This is an example of a report for a .NET application running on Windows. Here you can see the various applications. Well, you have the version of the engine running this application. You have the different libraries used. You have the different paths that have been discovered, the networking dependencies, whether you have a connection with an external database or not. You have a more detailed report per application that we provide, and this is all automated and provided through that report. Okay. The same for another. This is an example for a Java application. Again, you see the technological stack that is used, all the different libraries, versions of libraries that are used, the variables that are attached to that application, all the networking ports that are required to be opened, dependencies with external databases, etc., etc. And then you have some of the examples of the recommendations for these applications. Like, is this a 32-bit process that has been detected? No, right? So we know that we will need to download 64-bit libraries for that, where you need a lot of effort of migration, where you need to be careful about during that migration. Some risks that you have, right? If this is a very old version, you still have the dependency that can be downloaded, right? So this is also very, very key. And this is where we'll be building these recommendations to say, okay, migrate. This is worthy to be migrated, or no, don't migrate. Please retain or retire these applications. In terms of application that we support, we have tested. We know that works very well with that tool. You have applications running on various Java middleware. So Java applications running in vSphere. There are various versions of vSphere, WebLogic, GBoss, Tomcat, Wildfly, right? So we have these different applications running in these different middleware that we know that can be properly migrated. And these can run in different operating systems, whether they run in Linux operating system, Windows operating system, or IAX operating system. Again, in Linux, various distributions that we have tested. It's not finite. We have other distributions that we have tested, right, which have not been added to that deck. Windows the same. We migrated from very old versions of Windows, 2008 up to 2019. But again, we can adapt the tool to make sure that we are migrating from various modern or newer operating systems, and the same for IIX, right? Windows Stack. We have various applications running in IIS, .NET, ASP, .NET Core. Other stack that we have also tested in Python, Ruby, Apache, Node.js, right? Various frameworks that also can be migrated using application modernization platform. Okay. The databases, this is specific, so we tend not to do the database migration for various reasons. One, many of these database solutions have their own replication and migration tooling. So we prefer to then use that. And two, we are very cautious about manipulating customer data. So in that case, we prefer to do that through services, right? So again, using appropriate tooling with proper backups of this data and make sure that. So we can do the database migration, but we will be doing that through services and not through the application modernization platform. Okay, the application itself, whether it is middleware or front end, we can manipulate that through the tooling, but the databases will be managed through these services. And one important thing is we don't need the source code, right? Again, if you remember, here we are talking about lift and shift, so rehost or replatform. So basically, we are taking as is your applications from VMs or bare metal environments, and we are putting these in containers. So we don't need your source code, and we don't want to have access to your source code. When you will start to look at refactoring your application, then this is where you will be able to start to improve your source code, break it down, make them as microservices, make them run on as modern applications. But for that specific migration capability and tooling, we don't need access to your source code. The same for VMware towards OpenStack. We don't need access to source code. It's a lift and shift approach. We also have experience with which applications are hard, which applications are easy, which applications are mildly easy, and which applications are medium, right, in terms of complexity. So you have that map, right? Basically, you will see some of the applications like microservices are definitely, and which are stateless. Stateless microservices are the easiest to migrate, but the relational databases or message queues are more difficult to migrate. So what we typically recommend to our customers is to start with the easy applications. The reason we do that is simply that will also help you to understand how the tooling works, right? So you start with the easiest applications, and that kind of help you set the foot and understand all the different steps of the migration tooling. Once you have you understand well how that works, then what you can then start to do is plan for the easy, medium, and then hard applications at the end to start to migrate these applications, right? So that's some recommendations we would have. Obviously, ultimately, what will happen is that it will be a mix. So sometimes it will be a combination of easy and medium easy, or easy with some hard applications that we need to migrate, simply because we have some dependencies that we need to tackle. But ultimately, yes, our recommendation is always to start with a few easy applications, only to get used to the tooling. Okay. And how does that look at scale? So again, you have multiple migration windows. This is what we call waves. So basically, we will work. So we have a governance body. We will work with the internal owner groups. These internal owner groups will help us define all the different applications that we need to migrate. So all the different applications within VMs, right? So you don't need to migrate the whole VM, or you don't need to migrate the whole bare metal machine. You can select which applications you want to migrate within these VMs. So that's a big advantage also. So with these internal owner groups, we can define these waves after we have done the discovery, right? So we always start with the discovery. That discovery allows us to define a set of applications that we need to migrate, and then we define these waves of these migration waves. And during these migration waves, then we will have all the automation that I detailed. So basically, we containerize these applications. So we build the Docker files, then we build the blueprints to deploy, and then we deploy these in a target Kubernetes environment or multiple target Kubernetes environments. As an example, so this is a real life example of a customer that had to migrate 700 applications. And you can see that within 10 to 12 months, all these applications were moved from VMware to Kubernetes, right? So that's you can see some of these KPIs, like 20,000 plus human hours, and these are real KPIs in the sense that in the past we were doing that without the tooling, and we had to do a lot of things manually, like inspecting all these applications and defining the rules to migrate these, and per application it was taking us around 1 week or more than a week to only define the what we had to do around that application. So imagine that for 700 applications, right? With automation that we have built with application modernization and migration platform, AMMP, now we can do that in a way faster mode, right? So 600% faster to modernize these applications on a target Kubernetes cluster. What you have is we did the assessment during the first 3 months. Then we started to containerize these applications. What that means is we started to build the Docker blueprints, Docker file artifacts, and then containerize these applications and put them in a registry. And then in parallel, we had also to build the Kubernetes clusters. And when the Kubernetes clusters were available, then we started to migrate these applications, right? So this is why you see this in parallel. And ultimately, once the Kubernetes cluster was fully operational, then we continue to do the Kubernetes deployment until the full application portfolio was moved from VMware to Kubernetes. You can go then, once this is done, you can go a step further, and this is where the refactoring comes in. So you have your applications, you have done the lift and shift, or you have used the lift and shift approach, moved your application into the new target environment. The old environment is not needed anymore, so you are focusing now on Kubernetes. You have your operational team maintaining and managing Kubernetes. You have your application teams delivering on Kubernetes. Then your development team can start to use or cherry pick some of these applications and use or refactor the source code and make sure that they are applicable for modern applications with microservices. And then you can look at where to run these applications, whether this is on-prem or in a hybrid scenario. Okay. All right. So let's look at what that target environment will look like then. So we looked at one option of having OpenStack as the underlying infrastructure, right? And in that case, we would be doing the analysis of the applications and then convert these applications into virtual machines that would be managed by KVM, right? KVM as being the hypervisor. So that's option number one. Option number two would be to run Kubernetes on top of any operating system. Again, do the analysis of these applications and use AMMP. And at that time, instead of migrating these into virtual machines, you would migrate them into containers, right? And obviously, it's not one or the other. It can be a mix of both. So you can have OpenStack, run Kubernetes on top of that, and migrate your workloads inside Kubernetes. But these Kubernetes clusters will be running in OpenStack VMs. That's a very, very valid and I would recommend that approach definitely, because in that case, you are using a rock solid, secure, and fully open source solution. You are using Linux operating system, fully open source, OpenStack, fully open source, Kubernetes, fully open source, and run your workloads on these within these Kubernetes clusters, right? And ultimately, and for simplification, I just added Kubevert here. All right, definitely you wouldn't be running Kubevert on top of OpenStack, but again, this is just for simplification. But you can have Kubernetes plus Kubevert running on bare metal machines and then manage some of the workloads as virtual machines within Kubernetes. Okay, so that gives you a massive advantage of using fully open source, open clouds. So Linux operating system, OpenStack clouds, Kubernetes orchestration, and put your workloads within these open clouds. Big advantage is that you have that reversibility, and you can move from any vendor to another vendor when required, simply because you are using these open source, open clouds that allows you to have that flexibility to move applications from one side to the other. So how we Mirantis can help you? Mirantis, we have what we call the ZeroOps approach. The ZeroOps approach allows you to concentrate on your applications as we are doing the operations. And what I mean by that operation is we can help you define these open clouds, whether it is with OpenStack, whether it is with Kubernetes, whether it is with both, right? We have Mirantis OpenStack for Kubernetes. That is a very modern way of deploying and managing OpenStack. We have Mirantis Kubernetes Engine, which is a very well spread enterprise grade Kubernetes, which is used by many iconic companies like Visa, for example. And basically, we give you the guarantee of using these open source solutions, and we give you a path to success with proper design, proper deployment, and proper maintenance. But as I also showed you today, we have the capability to help you migrate from your existing environment, existing VMware environment, existing bare metal environment, and move your applications on these open source clouds, whether it is OpenStack or whether it is Kubernetes. If you want to learn more, we have more documentation on Mirantis Press, Mirantis blog, and these technical talks. You have the links here. I will be running another webinar next week around application modernization for cloud. So we'll be talking more about refactoring and how that can be applied to cheaper and flexible multi-cloud, again open cloud, right? So this is a continuity of this session. So thank you very much for your attendance. If you have any comments or suggestions, please feel free to reach out to myself and to Mirantis. Again, if you want to see demos of what I've showed today, if you want to have more details about what I discussed about the TCO model, or if you simply want to share your views on that session, again, I'm very happy to discuss with you. I will be very happy to discuss with you and get your views of that. Thank you very much for your time, and looking forward to have you in our next webinar.